Ever imagine the universe?
Like a giant.
It's a giant, like a giant, constantly shifting trampoline.
Right.
That's kind of what we're diving into today.
It's a good analogy.
With physicist Neva Author's book, booknewphysics.pdf.
Yeah. So this is a deep dive
Yeah.
into a single, incredibly dense source.
It's very dense.
That challenges everything we think we know about reality.
That's right. So
everything.
Yeah, everything.
At the most fundamental level.
I mean, literally everything.
Yeah.
Yeah.
What's fascinating about this book is that name of author,
Okay.
he doesn't just tweak existing physics.
Right.
He proposes a whole new foundation.
Wow.
Built not on particles or strings,
Okay.
but on this single ever-changing fabric
Right.
that he calls C-space.
Okay, so C-space.
Yeah.
Short for changing space, right?
That's right.
I'm already intrigued, but
Yeah.
before we jump into this trampoline universe,
Okay.
what's wrong with our current physics trampoline, so to speak?
Well, think of it this way.
Okay.
We've got amazing tools
Right.
like string theory and quantum field theory,
Mm-hmm.
which are great at describing what exists.
Yeah.
But Nema author argues that they're missing the actual machinery
Right.
behind reality's workings.
I see.
Yeah,
So it's like having a blueprint without an instruction manual.
exactly.
He's saying there's more to it.
There's got to be more to it than
Yeah.
just particles and forces, right?
Exactly.
Yeah.
And what
And
about...
he points out our reliance
Oh.
on abstract concepts.
Oh.
Things like probability distributions in quantum mechanics. Useful, but they don't quite capture the continuous flowing nature of reality that we experience.
Yeah, and what about the clash between general relativity and quantum field theory?
That's a key point.
Everyone's trying to unify them,
Right.
but they just seem fundamentally different.
Name of author suggests that this clash is because they represent energy in completely different ways. Like trying to fit square pegs in round holes.
Okay.
He's proposing a new shape altogether.
I like that.
Yeah.
So back to the C-space trampoline.
Yeah.
How does it solve these problems?
Imagine that trampoline again.
Okay.
Now picture it not as a flat sheet,
Okay.
but existing in 3 spatial dimensions, plus our rigid dimension of time.
Okay.
That's C-space.
So time isn't woven into the fabric like in space-time?
Right.
It's separate
It's separate.
and inflexible.
Separate and inflexible.
That goes against a lot of what we think we know about time.
It does.
Yeah.
But it's a fundamental difference in this model.
Interesting.
Yeah.
So is he suggesting that all the phenomena that we observe?
He is suggesting that
Okay.
space-time, quantum mechanics, even the particles themselves,
Right.
emerge from the behavior of this C-space fabric.
Okay, my brain's trying to catch up here.
I know.
So what we perceive as space-time is just us humans.
It's a human-centric interpretation of how this C-space is warping and stretching.
Exactly.
It's like we're little ants crawling on that trampoline,
Right.
only able to experience the dips and curves under our feet,
Right.
not the whole dynamic structure.
That's an incredible analogy.
I like that one.
And what about those weird quantum things like entanglement,
Yeah.
where particles seem to be connected across vast distances instantly?
That's where C-space gets really mind-bending.
Okay.
Because everything is ultimately part of this single fabric.
Okay.
There's no distance in the same way we normally think about it.
Right.
Entanglement isn't spooky action at a distance.
Yeah.
It's just 2 parts of the same interconnected fabric responding to changes.
So it's like 2 points on that trampoline
Exactly.
being pushed at the same time.
Mm-hmm.
They're linked by the fabric itself, not sending signals to each other.
That's a great way to think about it.
And even things like Heisenberg's uncertainty principle
Yeah.
and the second law of thermodynamics,
That's right.
they could arise naturally from how C-space behaves,
Yeah.
not as separate laws tacked onto reality.
He's getting rid of all the extra laws.
I like that.
Yeah, it's very elegant.
But we keep talking about this fabric.
Huh?
What about the stuff in the universe?
Right.
Where do particles come from if everything is just C-space?
This is where the idea of fermion carrier balls comes in.
Fermion carrier balls.
Fermion carrier
That
balls.
was
Now,
very
this is
cool.
pretty complex,
Yeah.
but imagine tiny, stable whirlpools forming within the C-space fabric.
Okay.
These aren't particles in the traditional sense,
Right.
but specific patterns of energy within the fabric itself.
So not little marbles,
Not little
but
model.
more like tiny self-sustaining tornadoes in the C-space trampoline.
Yeah, like little tornadoes.
Okay.
That's a good visual.
So these fermion carrier balls
Right.
could explain some of the most fundamental properties of matter,
Yeah.
like
Like spin.
the half-integer spin of fermions,
Right.
which are the building blocks of everything we see.
That's right.
Hold on. Are you saying that electrons?
I am saying that
Hang on,
quarks,
just hold on with that.
they're not tiny solid things,
They're not tiny solid things.
but these swirling patterns
Yes.
in the fabric of reality itself.
That's the idea.
That's crazy.
I know it's radical.
So C-space
Yeah.
is this dynamic fabric.
Yes.
Particles are patterns within it.
Uh-huh.
And even space-time is just our interpretation
It's an emergent phenomenon.
of its behavior.
Yeah.
But if all this is true,
Okay.
what are the implications?
The implications are truly profound.
How does it change our view of the universe?
Well, for example,
Yeah.
think about those cosmic mysteries. Dark matter and dark energy.
Right.
Name of author suggests that they might not be exotic particles at all,
Okay.
but large-scale distortions of C-space itself.
So instead of searching for some invisible particle,
Right.
we could be looking for these cosmic ripples.
It's a whole different way of looking at it in the fabric of reality.
Yeah.
And then there are black holes
Yes.
instead of infinitely dense points.
Right.
He proposes they're more like
Resonating cavities.
resonating cavities in C-space
in C-space.
with internal structure we can't currently observe.
That's right.
Wow, so black holes might not be the cosmic dead ends we thought they were?
Maybe not.
They could be more like strange, complex echoes within this fabric.
Yeah.
This is blowing my mind.
I know, right?
I can already tell this is going to be a deep dive unlike any other.
This is going to be a fun one.
We've barely scratched the surface of name of author's ideas,
Yeah.
and I'm already hooked.
I know, me too.
Yeah.
Yeah, it's a journey worth taking, especially because name of author,
Okay.
he doesn't just present this new model,
Right.
he digs into why our current experiments might be missing these
Right.
fundamental aspects of reality.
You know, that part really got me thinking.
Yeah.
He talks about limitations inherent in how we do science.
Right.
There's a huge point. Like our very methods.
It's almost like a philosophical problem.
Right.
Our very methods of doing science
Yeah.
might be blinding us to certain truths about the universe.
It's like we're trying to understand a giant symphony
Okay.
by only listening to the individual instruments one at a time.
Right.
We miss the overall harmony and how the pieces fit together.
That's a perfect analogy.
Yeah.
Name of author argues that
Oh, yeah.
this tendency to separate things
Yeah.
leads us to create models that might not reflect
Right.
the underlying unity of the
Right.
cosmos.
So we see particles and forces as distinct
Right.
when they might be expressions of a single deeper reality.
That's right.
And this ties into the limitations of our experiments.
Exactly. Think about the observer effect
Okay.
in quantum mechanics.
Right.
The very act of observing influences the outcome.
Right.
It suggests that our perception isn't passively recording reality.
Right.
It's actively shaping it.
Wow.
It's wild.
So how does this relate to C-space and the problems with our current theories?
Well, name of author believes that by focusing on individual particles and forces,
Right.
we're missing the forest for the trees.
Right.
We're trying to describe the behavior of separate entities
Right.
when they're actually interconnected aspects of this single C-space fabric.
This makes the idea of entanglement even more intriguing. It's like
yeah.
our current physics can't quite wrap its head around it
Yeah.
because it's assuming separation where there might be none.
Precisely in the C-space model, entanglement isn't spooky action at a distance,
Right.
but a natural consequence of the unity of everything.
Right.
It's not that the particles are communicating instantly.
Yeah.
It's that they were never truly separated in the first place.
Wow. So he even suggests that space-time itself might be a human construct,
Yes.
a way for us to make sense of the deformations of C-space.
It's a way for us to conceptualize it,
Right.
rather than a fundamental aspect of reality.
Okay, so our current ways of doing science, even our concept of space and time,
Right.
might be limited.
They're inherently limited by our human perspective.
So what does name of author propose as a way forward?
He suggests we need new tools
Okay.
and new ways of thinking to grasp this unity
Okay.
he's describing.
But how do we even begin to do that?
He believes mathematics could be key,
Okay.
but not the math we're used to.
Okay.
He introduces the concept of a continuum,
Continue.
a mathematical framework
Okay.
designed to represent the truly continuous nature of reality,
Right.
something our traditional number systems struggle with.
Hold on. Earlier we were talking about how our current math might be too abstract,
Okay.
relying on things like probability distributions
Yeah.
that don't reflect the seamless flow of reality.
Yeah.
How does this continuum solve
It's a
that?
very complex concept.
Right.
But think of it this way.
Okay.
Our usual numbers are based on discrete units, 1,
Yeah.
2, 3, and so on.
Right.
But reality might be more like a smooth, unbroken flow with no hard separations between things.
Okay.
The continuum is an attempt to create a mathematical language that can capture that flow.
So it's like the difference between a digital image made up of pixels
Yeah, I like that.
and a real-life scene, which is continuous and ever-changing.
Right.
The continuum is trying to capture the real-life aspect of reality,
Yes.
mathematically speaking.
Exactly.
And Name of Author believes that by using the continuum,
Uh-huh.
we might be able to create models of C-space
That's right.
that are more accurate and complete,
Yeah.
revealing how all these seemingly separate phenomena are interconnected.
That's the hope.
It's incredibly ambitious.
It is.
But there's one thing I'm still wrestling with.
Okay.
This idea of time as this rigid, separate dimension.
It's tough to wrap your head around.
How does that fit with our everyday experience?
Right.
We perceive time as flowing,
Yeah.
as being interwoven with space.
It is a difficult concept to grasp, but
Yeah.
Name of Author argues that what we perceive as time is actually a consequence of the constantly changing deformations of C-space.
Right.
Remember that trampoline?
Okay.
Imagine it continuously stretching and warping
Right.
in all sorts of complex ways.
So instead of time flowing,
Yeah.
it's more like C-space is constantly changing.
That's a good way to think about it.
And we're interpreting those changes as the passage of time.
Exactly. It's like we're riding a wave,
Right.
but we think the wave is moving through a static ocean.
Right.
When really the ocean itself is what's changing. And
Right.
because C-space is three-dimensional,
Right.
these changes can happen in countless directions.
Okay.
Which might explain why time seems to move forward.
Okay. So our experience of time is a consequence
A consequence.
of the multi-directional changes in this underlying fabric.
Yes.
That's a mind-bending shift in perspective.
It really is.
It leads to the conclusion that time might not be a fundamental property of the universe,
Yeah.
but an emergent phenomenon
Yeah.
arising from the behavior of C-space.
That's right.
It's not something separate from space,
Right.
but a way we experience the changes happening within this fabric.
Exactly.
I think I'm starting to see how all these pieces fit together,
It's starting to come together.
but it's definitely a lot to process.
Yeah.
And we haven't even touched on the specific predictions
Yeah.
and testable consequences of Name of Author's model.
That's where things get really exciting.
Okay.
Because if we can find evidence to support this model,
Right.
it would revolutionize our understanding of the universe.
I can't wait to dive into that next.
That's next.
This deep dive has been a wild ride so far,
It has been pretty wild.
and I'm eager to see where it takes us next.
Me too.
Okay, so we've spent the last 2 parts
2 parts, yeah.
really diving deep
Deep.
into Name of Author's C-space theory,
It's a big one.
this mind-blowing idea
Yeah.
that the universe is built
Mhm.
from
Mm-hmm.
a single ever-changing fabric.
Right.
But let's get down to, like,
Yeah, let's get practical.
brass tacks.
Brass tacks.
If this is more than
Yeah.
just a fascinating concept,
Yeah.
there should be ways to test it, right?
Absolutely. And what's exciting is that Name of Author.
Yeah.
He doesn't shy away from making specific predictions that,
Right.
in theory, could be verified through experiments or observations.
So this isn't just philosophical musing.
No, this is aiming to be science.
One that really caught my attention was this idea that the speed of light
Okay.
might not be
It's the big one.
as constant as we've always believed.
I know.
I mean, that's a cornerstone
yeah, it's a cornerstone.
of modern physics.
Right. It's almost sacrilegious to question it.
Yeah.
But remember, in C-space, the speed of light
Okay.
isn't a fundamental constant.
Right.
It emerges from the fabric's resistance to change.
Okay.
And since that resistance can vary across C-space,
Right.
so too could the speed of light.
But how would we even begin to test that?
Okay, Spice.
I mean, our current measurements are incredibly precise,
Yeah.
and they seem to confirm a constant speed of light.
Well, Name of Author suggests looking at extreme environments,
Oh.
places where C-space might be distorted in ways that we don't normally experience.
Okay.
Like think near black holes,
Okay.
or even looking back at the very early universe.
So we need to observe how light behaves in those extreme situations.
Yes.
And see if it deviates from what we expect based on a constant speed.
That's the idea.
And if we did find variations in the speed of light,
That would be huge.
that would be revolutionary.
Revolutionary.
Yeah. And speaking of revolutionizing our understanding,
Okay.
what about those other big mysteries?
Like,
Dark matter and dark energy.
right?
Does C-Space offer any insights there?
It does, and they're pretty radical.
Okay.
Instead of being caused by exotic invisible particles,
Right.
Name of Author proposes that they might actually be manifestations
Okay.
of the large-scale deformations of C-space itself.
Hold on. So instead of some new kind of particle, dark matter and dark energy
Yeah.
are just C-Space behaving
C-space, just doing its thing.
in ways we haven't fully grasped yet.
Yeah, like that trampoline has its
Yeah.
own energy.
Right.
It's got its own way of wobbling and flexing,
Right.
even without any objects on it.
Yeah.
Those large-scale wobbles in C-space
Right.
could be what we're detecting with the gravitational effects of dark matter and dark energy.
So it's not some invisible stuff
Right.
added to the universe,
Well, not added.
but the universe itself, this C-Space fabric, behaving in ways
That we haven't accounted for.
we haven't accounted for.
Right, exactly.
That's fascinating.
Yeah, and if this were true, we should be able to find correlations
Okay.
between the distribution of dark matter and dark energy and the large-scale structure of the universe as predicted by C-space.
And what about black holes?
Okay?
We talked earlier about how Name of Author suggests that they might
An
have
internal structure.
internal structure.
Right.
How could that be tested?
That's where things get really tricky. Because observing something within a black hole is,
Right.
well, impossible with our current understanding.
Yeah.
But he suggests that black holes,
Okay.
as resonating cavities in C-space, might produce subtle signatures, almost like echoes,
Okay.
that could be detectable outside the event horizon.
So not direct observation,
Oh, direct observation, no.
but looking for clues
Yes.
in how they interact with their surroundings
Mm-hmm.
based on this C-Space model.
Exactly.
Okay, let's be honest.
Boy,
Name of Author's ideas,
they're out there.
they're pretty far out there.
They're far out.
How does he address
Yeah.
the potential pushback from the scientific community?
He knows this isn't going to be easily accepted.
Okay.
He acknowledges that his work challenges
Yeah.
some very deeply ingrained paradigms.
It's a big change.
But he emphasizes that science progresses
Right.
by questioning assumptions,
Right,
exploring new ideas, even if they seem outlandish at first.
So he's basically saying,
Basically saying,
here's my crazy idea.
yeah,
Let's try to prove it wrong.
let's try to prove it wrong, exactly.
And at the very least,
yeah.
even if C-Space doesn't turn out to be the correct model, this kind of thinking
Yeah,
pushes the boundaries of physics.
it does.
It makes us ask deeper questions,
It does.
which is valuable in itself.
Absolutely. And Name of Author's work,
Yeah,
whether it's ultimately validated or not,
right.
serves as a powerful reminder that our understanding of the universe
Yeah.
is constantly evolving.
Yeah, what seems radical today.
Could be textbook science tomorrow.
That's what I love about these deep dives.
I know, me too.
They take us to the edge of what's known,
Uh-huh.
make us reconsider our assumptions,
It makes you think.
and remind us just how much there still is to discover.
So much.
And who knows, maybe Name of Author C-Space model will be the key
Maybe.
that unlocks a whole new understanding of the cosmos.
That would be great.
This has been an incredible journey.
Yeah.
And I want to encourage everyone listening to check out Name of Author's book for themselves.
Yeah.
Even if you don't agree with everything he says,
You don't like you think.
it's guaranteed to make you think in new ways
Yeah.
about the universe
Yeah.
and our place within it.
That's the ultimate goal, I think.
And that,
To keep questioning, keep exploring, and never lose that sense of wonder
yeah,
about the mysteries of the cosmos.
absolutely. Until next time,
Until next time,
keep diving deep.
keep diving deep.